Hello, this is Mr. Humbard here. I think for this video I'm going to be just walking through this assignment, giving myself some more practice. So to start, the SI unit for energy is the joule, or just J. The equation for kinetic energy is 1/2 mv squared. Equation for gravitational potential energy is going to be mass times gravity times the height. Kinetic energy of 5 kilogram object moving at 25 meters over seconds is going to be 1/2 the 1/2 mass, using this equation, times velocity squared. So 625 times 5 times 0.5. So that's going to be 1,562.5 joules. Alright, if we want to find the velocity for number 5, we have this mass, we have of 25, 1/2 mass times velocity squared equals 325. So to find that, we're going to find half of 25. So 12.5. Then divide 12.5 to both sides. And once we do that, we need to take the square root to find v, because that's v squared. We want just v. So our answer, put it here, is going to be square root 325 divided by 12.5. So 5. It's three numbers, so we'll say 5.1, because I get 5.099, and if I round this one to 3 numbers, there's my number over there, so I round that up, I get a 1 added to this, and then if I get a 1 added to this, I get a 1 added to that. So 5.10 meters over seconds. So mass of this object, there's our speed or velocity. Here's our kinetic energy. Velocity, kinetic energy. We want the mass. So 730 equals 1/2 m, which we don't know, times 35, which we do know, squared. And from here, I want the mass, 35 squared, divided by 2, 600, so 612.5 equals 730. That's not writing. $730. So M equals 730 over 612.5. And that's going to give 1.19 kilograms. If I want to check that, I could do 5 times 1.19 times 35 squared. Should give me around 730. So that looks about right. 1.19 kilograms. All right. Gravitational potential energy of this mass that goes to this height. So 35 times 9.81 times 2.5, because mgh equals potential energy. I mean, I'm going right to left for some reason, but running out of room. So 35 times 9.81 times 2.5. So 858 joules. I guess technically, since there's 2 here, we'd only keep the 2 significant figures, so we do 860 here. It doesn't matter that much. All right. So if we want to know the mass an object has, if it has this much potential energy, it's that high, we just plug in our equation, 725. So potential energy equals mass times the acceleration due to gravity times the height. We don't know the mass. We do know acceleration due to gravity. And we know the height, 3.7. And from here we can find the mass by just putting those numbers on the other side. So 725 over 9.81 and 3.7. By 9.81 times 3.7. So mass is 19.97 kilograms. Or if we're rounding this to 2, I suppose it's about 20. All right. Looks like I need to erase this. It's 25.5. So we want the height, so 550 mgh is our potential energy, 550 joules, equals mass times the, which is 25.5, so we know that, times the acceleration due to gravity, 9.81, times the height, which we don't know. So height is 550 over 25.5, 9.81. We should get 550 divided by 25.5. Oops, I need parentheses there. Times 9.81. And I made sure to include a parentheses here because otherwise I can make a mistake and forget to not divide by everything. I should get 2.191 We'll just say 199 meters. For 27, the kinetic energy of an object, if it changes its speed, if it doubles, then if we use the kinetic energy equation, here is the initial kinetic energy. If we double the speed, our velocity doubles as well. So this part doesn't change, it's just the velocity doubles. And we're going to get our original times 4. And if we do a similar thing with triples, we're going to get the original times 3 squared, or 9. So if we double it, our kinetic energy quadruples. If we triple it, our kinetic energy goes up by a factor of 9. All right. So the change in potential energy is not the same on Earth as it is on Moon, because the acceleration due to gravity on the Moon is very small compared to Earth. And if we have a smaller acceleration due to gravity on the Moon as compared to the Earth, and the potential energy is mass times gravity times the height, acceleration due to gravity times the height, then the change in potential energy will not be the same. In fact, it will be smaller on the Moon as gravity is smaller on the Moon. Acceleration due to gravity. All right. So another problem with a mass and a energy. Wanting to find the speed. So 7.8 equals 1/2 0.27 times velocity squared. Velocity is 7.8 times 2 over 0.27 square rooted. Just a little bit of quick math. So V 7.8 times 2 divided by 0.27. Then square root that answer. So it should give me 7.6 meters over seconds for the answer to 33. For 35, I think that is. If we want to find the potential energy, 0.14 times 9.81 times 16 is mgh. So let me just find that. We should be getting 21.97 joules. All right. Let me quickly check that other answer. Yeah. So for this 79, we're going to rank these in order of increasing kinetic energy. So kinetic energy is 1/2 mv squared. And here we'll plug in all our values for this. So A is just going to be the original. B will be 1/2 times m over 2 times 9 v squared. And C will be 3m over 2 is 1/2 times v squared over 4. And then we have D. So 4m over 2 times v squared over 4, which that is going to cancel with this one. So it looks like D is the same as A. And it goes 3 over 8 mv squared, 9 over 4 mv squared, and 1/2 mv squared and 1/2 mv squared. So the answer is going to be, in order of increasing kinetic energy, A and D from the bottom, or actually the bottom is it's going to be C. It's 3 over 8. And then it's going to be C, A, and D, which are tied, and looks like B is at the top. If there is not a possible way for the kinetic energy to be negative, as energy is a scalar. It is possible for the change of a kinetic energy to be negative, though. So if you have a change in energy, it's possible for that to be negative. But kinetic energy is not possible as 1/2 mv squared. No matter if v is positive or negative, it's squared, so the negative will cancel out. And that is that assignment.